Hello again. I'm recording this third session today from chapter 4, and this session is about resultant forces, but resultant forces in 3D. So let's start with this problem. Let's read this problem and see what happens here. It says the building slab is subject to 4 parallel column loadings. Determine the equivalent force, 4 parallel, 1, 2, 3, 4, resultant force, and specify its location XY on the slab, and take F1, well, they could write here, could have written here F1 30 and F2 40. Okay, 30, 40, 50, 20. So basically what the problem is telling us once again is finding a resultant force somewhere, apply, and that somewhere apply is going to be some amount in X and some amount in Y that produces the same effect as the other forces. Same procedure like 2D. Summation of forces is going to give me the resultant force. So my resultant force is going to be 20 plus 50 plus 30 plus 40, because all of them goes in the negative K direction. So my resultant force is going to be 140 K negative. Now, I'm going to work this problem as a Cartesian approach. I'm going to convert everything like vectors. So let's start from the beginning. I'm going to start calculating the summation of moments. Summation of moments of each one of the individual forces. Let's start from there. The first force, I'm going to use this force of 20. Remember, my moment is R cross F, not F cross R, R cross F. So let's start with this force of 20. That force of 20 from this point, which is the origin, the arm is going to be this one, and this one means 10 in the I direction. So my R is going to be 10I cross the force, and the force is negative 20K. Done that one. Now for the second force. The second force is this one. The arm is going to be from here to here in Y and from here to here in X. So this distance in X is 4I, and this distance from here to here is 3J. 4I plus 3J, that's the R, multiplied by the force, but the force is negative 50K. Let's keep going. Let's keep going to this force now. This force here, the R is from here to here directly, and this value is 3 plus 8, 11. 11 in the positive direction of J, multiplied by the force, and the force is negative 30K. It's good. And last but not least is this other force, and for this other force it's going to come up to here and then up to here. That means that the R is going to be 10 in the direction of I, and in the direction of J is 3 plus 8 plus 2, that means 13. Cross multiply by the force, which is 40, negative 40K. Okay, let's solve this. For solving this, remember I show you or exist a little tool that I use at least for cross product. Basically, what I said is everything that I multiply in this direction is positive, and everything that I multiply in this direction is negative. I cross j is positive k, but k cross j goes against the arrows. So k cross j is going to be negative I. So let's do I cross k. I cross k is going to be negative j, but I have a negative sign here. That means that it's going to be positive j. 10 times 20 is 200j. I cross k, negative j times negative positive, 4 times 4, positive 200j. J cross k is positive, but I have this negative here in the k, indicating that's going to be negative. 3 times 50 is 150i. J cross k is going to be I. J cross k is going to be I, but I have this negative sign there. So it's going to be negative 330 I. J cross k, yes, I. Then I cross k is negative j times negative is positive j, and 10 times 40 is 400j. And j cross k is I, but I have this negative here, so it's going to be negative, and 13 times 40 is 520i. Then you add everything that is in I together and everything that is in j together, and then when you do that, you get this plus this, or this plus this is 850,000, negative 1,000 I, and 800 j. That is the summation of moments of all the individual forces. But at the same time, I know that this resultant force of negative 140 placed at the distance xi, I say x and y here, it's the opposite, this is x and this is y. So at the distance of xi and yj has to produce the same one. So my arm for the resultant is going to be xi plus yj, cross multiplied by that value of the force, negative 140 that I know, k, has to be equal to these ones. That's basically what I have. I cross k is negative j times negative is positive j. So 140xj has to be now j cross k is negative I times j cross k is negative, j cross k is positive, positive, negative, negative I, negative 140 y I has to be equal to negative 1000 I plus 800j. And because it has to be equal to this negative 140i has to be equal to this negative 1000i. Negative 140y has to be also equal than this y I has to be equal to negative 1000 I, and this negative, positive 140x has to be equal to this 800 because both are in j. From here you can calculate that x is equal to 5.71 meter and y equal 7.14 meter. So what the problem tells you at the end is that all of those forces located in the way they are produce the same effect as this force of 140 located at 5.71 in x and 7.14 in y. That is a nice problem also. Okay, I have another problem for today. And the problem that I have for today, the last one that I'm going to do now, is this one, which is fairly similar to the one that I just solved. The only difference is the approach that I'm going to use for solving it. But you can do it exactly in the same way that I did it before. I just don't want to do it in that way. So you can have different ways of, or different alternatives. Some people like one more than the other. I just use them independently, whatever is easier for me in that moment. So basically, it says determine the magnitude of FA and FB so that the resultant force passes through point O. I know the location now of the resultant force. The resultant force is here. By the way, that's basically what most of the time we look for, making the resultant force concentric to the column, because in that way there's no moments in the columns, and that's not very good having moments in columns. We discussed that in class also. So what do we have to do? If I want to calculate my resultant force is going to be the summation of all the forces, FB plus 6 plus 8 plus FA, or I can say that my resultant force is going to be FA plus FB plus 14, and that is acting in this direction, which is negative K. I know that. But I also can now, I also know that if I do summation of moments with respect to this point, it has to be 0. Why 0? Because the resultant force passes through that point, and if I say summation of moments of the resultant force has to be equal to the rest of them, the summation of the rest of them, the summation of the moments that the resultant force produces with respect to that point is 0. And that's a huge piece of information that we have. So basically I'm going to do summation of moments of all the forces with respect to this point and make it 0. But instead of doing it in Cartesian approach, I'm going to do it in a scalar fashion. So I'm going to see each one of the forces, how makes the moment to rotate about the axis, or the object to rotate about the axis. For example, this force FB is separated a distance of 750, I'm going to say 0.75 meters, and that force B, 750, if I apply the force over there in that location, is going to produce a rotational movement of the body around the positive direction of the x-axis. Just see it, apply the force here, and that's going to try to rotate in that way. So that means that it's going to be positive, because it's going to the positive direction of the axis. This 6 times this distance of 0.65, same story. Because if I am here and apply the force here, that's going to produce a rotational movement with the x-axis. Now, what about this one? If I apply this force of 8 in this direction, the rotational movement about the x-axis is going to go in. Do you see that? Apply the force, keep the pin here, and now imagine how it's movement. It's movement entering into the axis. So that's going to be negative 8 times this distance. This distance is 0.7. And this other force is going to produce the same effect. Negative, in this case, 6, 0.6 FA. And I know that has to be 0. Because the net moment with respect to that axis has to be 0. When I organize this, basically what I have is negative 0.6 FA plus 0.75 FB minus 1.7 equals 0. And I get one equation. Now we do the same thing about the y-axis. And then I go about y-axis. I didn't put this, but moment about x has to be 0. And I'm going to do summation of moments about y has to be 0. Y-axis now. Now you study this force, but the rotation about the y-axis. So if I apply the force in this location, that force is going to produce this rotation about the negative axis. It's going to be negative FB But now the distance is this one, because this is the distance that is making the point rotate about that axis. And that's 0.15 FB. When you go to this one, now the story is different, because if I apply the force here, the rotation is going to come in this direction. It's trying to make the rotation of the body around the axis in this way, and that is going to be positive 0.1, which is the distance, times 6. Now when you move to this one, rotation of that force, when I apply it here, is going to be 8, the value of the force, times 0.1, the value of the distance, and it's going to make the rotation in that direction, meaning negative. And this force acting here is going to cause the rotation to come in this way. So that is going to be positive 0.15 times FA. And that has to be 0, because I know that the summation of the moments also in Y has to be 0. Now I reorganize this and I put 0.15 FA minus 0.15 FB. This is negative 0.8, this is positive 0.6, negative 0.2 equals 0, and I have equation 1, and I have equation 2, and I can say that this is equation 3. Then I multiply this times 4 to solve the system. This is going to be cancelled with this one. This is 4, this is 0.6 negative, this is positive 0.75, that means 0.6, 0.75 is going to be negative, positive 0.15, and this is 0.8, 0.9. So that basically what you have here is negative 2.5 is 0.15 FB equal or minus 2.5 equals 0, and FB equals 16.67 kilonewton. I plug this into 2, or I plug this into 1, and I can get my value for FA, which is 18.00 kilonewton. And then I plug these 2 in 3, and I get my resultant force. And that's the problem. Now, what I would like you to do is try to solve this problem using Cartesian approach, and try to solve this other problem using the approach that I showed you in the last one. One more time, guys, have a good day. Go through the problems, try to solve, practice, 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 and do not procrastinate. I really want you to succeed in this class, and trust me, I'm doing my best. So I'm posting these video lectures and these session problems, and I hope that you actually are watching and enjoying them and understanding the material. That's the most important part. See you later, guys.